Along the old western shore of Puerto Rico, the coast that Columbus explored, where Drake and Morgan sailed, across the fields of sugarcane rises a dome of the future. Bonus, first nuclear power plant in the tropics. Bonus, for boiling water nuclear superheat, is one of the Atomic Energy Commission's power demonstration projects. With its superheat core, it represents one advanced step in AEC's program for the development of power reactors. And AEC is meeting 3/4 of the total cost of about $24 million. Surrounded by the complex plumbing of nuclear technology, silent and clean as no conventional power plant has ever been, the new reactor will supply superheated steam to a turbo generator designed to produce about 17 megawatts of electricity. A continuous supply of baseload power. Although Bonus is not a large plant as nuclear power reactors go, it forms part of an ambitious plan to supply this island with the power its blooming economy needs. Bonus will join the conventional generating facilities of the Puerto Rico Water Resources Authority, co-sponsor of the reactor project. A power grid built up largely during the past 25 years, a foundation for the industrial development of the island. And so in 1960, the interests of the Commonwealth of Puerto Rico and the United States Atomic Energy Commission converged on this lonely headland of Punta Higuera. The work of clearing the site began. To the formal groundbreaking ceremony came those concerned with the future of this Commonwealth and with progress in the peaceful uses of nuclear energy. People like Governor Munoz Marin, and Rafael Urrutia of the Water Resources Authority. Congressman Chet Hollifield of the Joint Committee on Atomic Energy. Together, they moved the first symbolic shovelful of earth, a token of the joint effort that would unite Americans of the island and the mainland in the months ahead. For Bonus is being created through an interlocking pattern of cooperation. AEC is responsible for and will own the nuclear portion of the plant. The Water Resources Authority will provide the turbo generator and other conventional facilities required and will operate the entire plant. In turn, AEC has contracted with the Maxon Construction Company working from designs prepared by Combustion Engineering Incorporated and Jackson and Moreland. At the same time, far from this site of Punta Higuera, other elements of bonus are beginning to materialize. At the Pacific Coast Engineering Company's plant in California, the reactor's pressure vessel takes form. This is one of the most critical components of the reactor, and it's certainly the biggest. Through grinding, welding, and drilling, its 61 tons are shaped to the most exacting standards of integrity. For this vessel must contain the reactor core, the nuclear furnace, a tempest of boiling water and superheated steam. The fundamental achievement of the atomic age, a controlled nuclear chain reaction, is put to work in the power reactor. The heat energy of the fission reaction is harnessed to produce steam, to turn turbines, to generate electricity. The Atomic Energy Commission has sponsored the design and development of a number of different types of power reactors to gain broad experience for future large-scale development. Bonus is an outgrowth of a power reactor concept that uses water as the moderator, reflector, and coolant. That is, the steam produced in this central boiler region at a temperature of 540 degrees Fahrenheit is passed through special superheater fuel elements located on the periphery of the core. No auxiliary heating is necessary. The superheated steam flows out of the reactor core at 900 degrees Fahrenheit and 850 pounds per square inch. Temperatures and pressures for most efficient use in the latest types of turbo-generating equipment. It's February 1963, and the bonus pressure vessel has reached the harbor of San Juan. Now another part of the job begins, to move this 61-ton object across the length of the island without a scratch or dent to its precisely finished features. At Punta Higuera, the containment shell has been completed. A gas-tight building constructed to hold internal pressures of 5 pounds to the square inch. It will house all of the reactor and generating facilities. The turbo generator has been installed by the Water Resources Authority. The space beyond awaits the pressure vessel. Now, like the key piece in a giant jigsaw puzzle, it moves into place. Once the pressure vessel is in position, it will be wrapped and embedded in a 10-foot shield of steel, water, and concrete. Meanwhile, the innumerable connections are being completed. Steam outlets from the superheaters, water recirculation piping, and all of the other facilities that will feed and cool, control and safeguard the reactor. The instruments that will analyze its moods and responses. Into the waiting pressure vessel will go the internals, the core structure that holds the uranium fuel assemblies amid a torrent of water, 9,000 gallons per minute. Once installed inside the pressure vessel, the core structure will not be removed. This is the last look, the final inspection. Impurities cannot be tolerated in a reactor system. At this stage of installation, the requirement for cleanliness, always rigorous, becomes absolute. Because the bonus reactor is intended to fill a specific need, illuminating one area in research and development, it differs from every other reactor in its design, its engineering, and construction. Of the $18 million being expended by AEC on bonus, a sizable amount must go into research and development. Each of AEC's reactor projects imposes demands upon the designer and engineer that are different and difficult. Problems that must be solved each time from the origins of their complexity. Beside technological know-how, what else is going into the building of bonus? There are thousands of hours of plain, hard, physical labor, work that differs from routine by the need to meet exacting standards at every step. There is the slow increase in knowledge that comes from one day to the next, from one project to the next. The growth of experience in the ways of harnessing and handling this new source of power safely. And there is the unexpected setback, breaking abruptly into the schedule. This time, it's one of the recirculating water pumps. This whole phase of installation comes to a halt as the mechanics work intently to fix it. Estimated delay, 3 days. Actual recorded delay, 5 hours. Slowly, in all of its complexity, the reactor takes form. These are control rod drive units. They will power the 2 types of control rods whose movements start and stop the chain reaction and maintain safe operation. They must transmit the finest adjustment or drop instantly into the core when the scram button is pushed to shut down the reactor. Now, Bonus is being subjected to continuous cycles of testing as components are checked against components, systems against systems, and final adjustments completed. Finally, the reactor, complete and functional, is ready to receive its nuclear fuel, fabricated by combustion engineering. The finely wrought fuel assemblies, 96 of them, contain a total of 4.5 tons of uranium. One by one, they're lowered into place deep within the core structure. Into the boiler section go 64, enriched uranium oxide clad with zircaloy tube. For the superheater section, 32 fuel assemblies are provided. They contain enriched uranium oxide clad with Inconel, inserted within stainless steel pressure tubes for the passage of steam. The evening of April 13th, 1964 brings a culmination. It's called the initial criticality test, the moment when the reactor is to control nuclear energy for the first time. Everyone is busy tonight. The reactor operators at the controls, the other members of the staff double-checking the data that feeds off the instrument panels. .33 hours, April 13th, 1964. In the long succession of events that marks any major construction project, this is one of the peaks, when these men can look back over their work and look forward into the future and find both of them good. Bonus is producing power under the operation of these staff members of the Water Resources Authority. They were trained at the AEC's Puerto Rico Nuclear Center and other AEC sites. AEC is paying the costs of operation while the Water Resources Authority is purchasing the steam produced by the reactor from AEC. Then, out of this cooperation, power from Bonus is moving across the green hills to the cities and farms and factories of Puerto Rico. knowledge and practical experience obtained through Bonus is helping bring power, cheap, abundant power, to many parts of the world.